How did a venomous lizard, one that could actually kill you, end up behind Ozempic? It's one of the strangest stories in modern medicine. You've heard the names by now: Ozempic, Wegovy, Mounjaro. By some counts, around 1 in 8 American adults has taken one. They quiet the signal in your brain that says, eat. They've reshaped diets, headlines, entire industries, but none of it started in a lab trying to cure obesity. It started with one quiet scientist, one strange lizard, and a question almost everyone else thought was a waste of time. Could a creature built to survive on almost nothing teach us how to control our own hunger? The answer wouldn't come from a gleaming research lab. It would come from a quiet veterans hospital in the Bronx in the early 1990s, from an endocrinologist named Dr. John Eng. He wasn't chasing a blockbuster. He wasn't chasing anything, really. He was just curious. Other scientists had noticed something strange, that certain animal venoms contained hormones, the same kind of messengers our own bodies use. Eng couldn't let that go. If venom could hide a hormone, what else was hiding in there? So he started working through venom, piece by piece, and one animal stood out: the Gila monster, a lizard that spends its life underground and eats just a few times a year. Eng had a hunch. An animal that goes months between meals might have some very unusual chemistry for handling food. In 1992, he finds it, a brand new molecule buried in the venom. He names it Exendin 4, and when he looks closely, it's almost a mirror. It looks strikingly like a hormone we already carry, something in our own gut called GLP-1. Now, this is where the story should end, because if the lizard's version is just a copy of a hormone we already have, who cares? And GLP-1 is remarkable. It tells your body to release insulin right when you need it. Scientists had known about it for years, but there was a wall, a big one. Our own GLP-1 dies almost instantly. An enzyme in your blood, called DPP-4, hunts it down and tears it apart in about 2 minutes. 2 minutes. You can't build a medicine out of something that vanishes before it can work. For years, that stopped everyone. Except the lizard's version didn't break apart. Same message, same job, but built differently. Just different enough that DPP-4 couldn't grip it. So it lasted. Not minutes, hours. And suddenly, Eng's little curiosity was the most interesting molecule in medicine. And that steady message does 3 things. 1, it nudges the pancreas to release insulin, but only when your blood sugar is actually high. 2, it slows your stomach. Food lingers. You stay full longer. 3, and this is the one nobody expected. It reaches the brain, the part that decides you're hungry and turns the volume down. But here's the part that gets me. When Eng brought this forward, almost no one was interested. His own institution, the VA, passed on it. It wasn't a veterans problem, so they saw no reason to. So Eng did something extraordinary. He filed the patent himself. Out of his own pocket, he believed in a lizard hormone when the world wouldn't. For years, he couldn't get a single company to take it seriously. So he did the least glamorous thing imaginable. He set up a booth at a diabetes conference, just standing there, waiting for someone to care. And eventually, someone did. A small biotech company stopped at his booth. That was the moment everything turned. In 2005, that lizard molecule became a real, approved medicine, the very first of its kind. A drug for diabetes, grown from venom. And it worked. And once scientists had one version that could survive, they built better ones, steadier, stronger, longer lasting. That family tree leads directly to the drugs reshaping the world right now, including the one you came here for, Ozempic. It isn't the lizard's molecule itself, it's a great-grandchild of it. But every branch on that tree traces back to one stubborn scientist and one venomous lizard. Years later, Eng was given an award, the Golden Goose. It honors research that sounds pointless until it changes the world, which is the whole point. The most valuable medicine of a generation didn't come from a war on obesity. It came from publicly funded, curiosity-driven science. A man who looked at a venomous lizard and simply asked why.